Hi guys, we're moving on from straight lines or linear lines now, and we're moving into quadratics. You've seen lots of quadratics in your Year 9-10 course, and we've solved lots of quadratics in the algebra section. Quadratics are also called parabolas. Okay, so a quadratic function gives the graph of a parabola, and it takes this form. It takes the form y equals ax squared plus bx plus c. So we've looked at them, and they've looked like things like x squared plus 2x plus 4, for example. And they were the ones we called monic because they had no amount of 1 out the front of the x squared. And we had a look at other ones, for example, 3x squared plus 3x plus 1, for example. And there was a number out the front, and we called those the non-monic. So we got used to factorizing these in the algebra topic. And that's what we're going to be doing in order to graph our quadratics in this topic. Okay, so what we're going to be looking at is some steps to curve sketch a quadratic. Now remember, I said we don't want to plot our graphs this year. We want to be sketching them. So when we're sketching them, we're looking at y-intercepts, we're looking at x-intercepts, and we're looking at which way the graph is. Is it we call concave up or concave down? And we haven't had, you probably haven't seen a lot of that yet, but that's what we want to start off with this morning. Okay, so 4 steps to curve sketching a quadratic. Step 1 is determine if the parabola is concave up or concave down. So let's have a look at the first little parabola here that I've drawn. Y equals x squared plus 2x plus 4. Now, we haven't solved it yet. We haven't had a look at where it cuts the x-axis or where it cuts the y-axis, but we've got basically 2 choices with that graph. It can either go this way, okay, or if I draw another one, it can go upside down, go the other way, go this way. We've got 2 choices, and we can quickly decide straight away which way that will go. So what I'm doing is looking at what happens to my number out the front of x squared. If that number out the front of x squared is a positive number, then my graph looks like this. It's a smiley face, basically. Okay? It is concave upwards. It's pointing upwards. And what we would have there would be a minimum value down the bottom. The same for the second one here. Y equals 3x squared plus 3x plus 1. My number out the front of the x squared is a positive number. It's a smiley face. It's concave upwards, and we'd also have a minimum value down the bottom here. Now, that would be the case also in this generic form. Y equals ax squared plus bx plus c. A here, we're assuming is a positive number because I haven't got a negative in there. If it is positive, it's concave upwards. If this number out the front of my x squared is a negative number, or it's less than 0, our graph flips to the other way. Okay, so that would be, for example, a graph that looks like y is minus x squared plus 2x plus 4. Or y is minus 3x squared plus 3x plus 1. Okay, those have a maximum point at the top up here, and they're called concave downwards. So straight up, we should be able to see or understand the way our graph is going to point. And we can always look at that as the first point. The other things we're going to have a look at for graphing our graphs are point 2 and 3, which we've been doing with our linear straight lines, okay? Where does it cut the y-axis? When x equals 0. With this part here, what we're doing is we're solving the quadratic, which is what we did in the algebraic topic. Okay, if we've got a quadratic, we're popping it into our brackets, and we're setting, for example, this, and we're setting each bracket to 0. I've just made this equation, this quadratic up here. But that's what we did to solve it. And these would be where we cut the x-axis, and they'd also be called our zeros, which we haven't really talked about that before. But where it crosses the x-axis would be our 0. Sorry, I've got that on the wrong one there. So that would be our x-intercepts there. Okay, and we also have a look at where it cuts the y-axis, and that's where x is equal to 0, and that's going to be generally, if we've got a constant term, it's going to be our constant term at the end. So if I was to set each of these parts to 0, we'd end up with where it cuts the y-axis up there. So they're things that we've been doing and we can do. The fourth one's a little bit new, but I have shown you this before. The fourth point says to find the axis of symmetry. So remember, with all of our parabolas, okay, all of our parabolas, if we were to find where that center line was, the axis of symmetry, and we folded that parabola along that center line, our parabola would be symmetrical on both sides. So when we looked at functions and even functions, our y-axis was our axis of symmetry, but that's not always going to be the case. So sometimes we need to find the axis of symmetry, and generally that's going to lie between our two points, or if we have 2 points where our graph crosses the x-axis, the axis of symmetry is going to be between those two. But we'll have a look at that in a minute. But our point 4 here says find the axis of symmetry by finding the average of the x-intercepts. That's just saying finding the point that lies halfway between those x-intercepts, and that's going to be the x value of our axis of symmetry. So it's actually quite sensible if you think of what's actually happening if you were wanting the graph to find where that graph was symmetrical. So think of that fold line. It's called an axis of symmetry. Find that midway point, and that's our x value. We'll also find an equation for that next lesson. It says use the x value and substitute back into the original equation to find the y coordinate. So if this, and we'll have a look at this in a bit more detail, but if this was my parabola here, okay, that's not a particularly well drawn one here. If these were my zeros, or where it cuts my x-axis, midway between those is about here. That's my x point. But if I substituted that value back into my quadratic, I'd get the corresponding y value and know what that point down here was. And that's what we need to do. That's giving us the gist of a quadratic. Is giving us the sketch, the values that need to be sketched. We don't want to draw our little x and y boxes, and we don't want to put values in for that. We don't want to do that anymore, okay? That's not what we're doing, okay? That is plotting our graph. We don't have time for that. We need to look at other values, and those other values that we're looking at are going to help us when we move on to calculus really soon as well. So we're looking at deciding, is our graph a smiley face? Is it a sad face? You can think of it like that. If it's a smiley face, then we're positive. Okay, think happy, positive. Sad, frown. So negative, frowny face. That's probably the best way to think of it. It's not very mathematical, but that's how I like to do it. So let's decide that first. Find where it cuts the x-axis, find where it cuts the y-axis, find our axis of symmetry, and we're done. Let's have a look at one now. Let's have a look at this one down here. Example. It says sketch the graph y equals x squared minus 4x plus 3, showing all important features. State the domain and range. I'm just going to do that on this page here, but you will find that this is already done in 308. Here, it's the one that's on the board, but I'll work through that with us together over to the right here now. Okay, so here's our graph here, our quadratic. I've just written the one from the equation over here, y equals x squared minus 4x plus 3. Let's see what we know about this quadratic. Well, step 1, I can see that it's going to go in this direction, okay, because my number out the front of the x squared is positive. So straight up, I know that's the way it's going to be. So when I plot my zeros on my points where it crosses the x-axis, I'll know that that's the direction that it's got to go. So let's look at it. Let's look at where it cuts the x-axis. And it cuts the x-axis at y equals 0. So let's pop a 0 in where y is, and we've got 0 equals x squared minus 4x plus 3. We can solve that. We got really good at that. I'm just going to pop the 0 over here. Looking at that, we know that it's going to multiply to 3. It's going to add to minus 4. What are our factors that make that work? Let's think about that. Okay, so what we're going to get is we're going to get minus 3 and minus 1. Minus 3 plus minus 1 is minus 4, and minus 3 times minus 1 is 3. So they go in there, minus 3 and minus 1. That equals 0. We're solving it. Okay, let's put a little dot there so we know where we're up to. Let's set each part to 0. So x minus 3 is 0 and x minus 1 is 0. Adding 3 to both sides give us, on this case, x is equal to 3. And on this side, x is equal to 1. This is where my graph cuts the axes. They are called my zeros. Just a new word for today. Okay, let's find where it cuts the y-axis. Now, you know that already. It cuts the y-axis at x equals 0. So here's my quadratic. Let's pop in x equals 0. It's going to be 0 squared minus 4 times 0 plus 3. And that's going to be at y is equal to 3. There are our first two things our first three things we've done over from here. Let's have a look. So we've looked at determining if it's concave up or down. We've looked at where it cuts the y-axis and where it cuts the x-axis. Now let's find the axis of symmetry. You know what I might do before I find the axis of symmetry? I might draw it. Let's draw our axis. Now if you've got a ruler, please do that. Okay, so it's going to cut our x-axis at 1 and 3. So let's pop in a 1, a 2, a 3, a 4. 1, 2, 3, 4. We can still pop a couple of other numbers in there if we like. It's going to cut here, and it's going to cut here. Now we know the shape is this way because we said it's a happy parabola. There's a positive number out the front of the x squared. So we know we don't want to go that way. We don't want it to be negative. So we know it's going to go this way. We just need some other information. We know it cuts the y-axis at y equals 3. So let's pop that in. 1, 2, 3. Okay. So it's going to cut through there. It's going to go down here and up here. So let's do that before we put our axis of symmetry in. It's going to go down here, up like this. Okay. There's one more thing we want to do. It's our axis of symmetry. Now, what we suggested that you do today is to find the number that's halfway between 1 and 3. And in this case, it's going to be 2. If you're unsure, we add 1 plus 3, we get 4 and we halve it. But that one's quite simple, 2. So our axis of symmetry happens at x is equal to 2. So that point down there is 2 something. We need to find that something. It's a y point. So let's change that question mark to a y. How would we do that? Well, we know x is equal to 2, and that lies on the parabola. So let's pop that x into that parabola, and we'll get a y value. Okay, so let's do that. So the axis of symmetry, excuse my spelling there. Oops. Occurs at, sorry, I'm writing this while I'm sitting on the lounge. X equals 2. So what's the y value? Y is equal to 2 squared minus 4 times 2 plus 3. I've substituted x equals 2 into my parabola there, and let's see what we get. Y is going to be equal to 2 squared is 4 minus 4 times 2 is 8 plus 3. Okay, so y is 4 minus 8, which is minus 4, plus 3, which is minus 1. So that tells you that my axis of symmetry is happening at x equals 2. But what happens down here, that gives us our minimum point. So that is a minimum point. It's the most smallest or the most minimum, doesn't sound very great English there. It is the lowest point on our parabola. It happens where the axis of symmetry is, it's x equals 2, and the corresponding y value there is minus 1. So it's called a minimum. If our parabola was to go the other way, if it was a negative parabola and we had a minus out the front of the x squared, the point we would be looking for would be a maximum if we were looking at the axis of symmetry, and that maximum point, it just so happens on a positive parabola, we have a minimum point.